Okay, so I started the recording. Hi everyone, I'm Casey. I'm the peer tutor for Chem 30A, and thank you all for coming to my workshop. This is to help you prepare for the first exam, which is next week. So hopefully everyone's feeling a little bit good about studying. So for right now, I have my hours listed on the screen and a little bit of instructions on how to set an appointment with me, because I do have one-on-one appointment-based tutoring sessions that can be set up through Smart Connect. And if you have questions on how to set an appointment up with me, you can stay a little bit after the workshop and I can help you with that as well. So for today, I will be recording this meeting and the center will upload it on YouTube by Saturday morning. I have a, link to a survey, and if you all could do it, I can then get your email so I could send you a copy of the PowerPoint slides. So let me do that real quick in the chat. And I will also send the link to the channel, the YouTube channel. So the first one is going to be the Google form. That's the survey. And then here is the link to the YouTube channel. Okay. I also have live transcription, like subtitles that you can turn on if you'd like. But other than that, let's get started with the workshop. So these are the topics that I will go over. Oh, okay, here, let me resend it. Okay, thank you for letting me know. That's weird. That's weird. Okay. Let me try resending it. Okay, do you see the first YouTube link? Yes, okay, the YouTube one. Okay, cool. So here is the YouTube or the Google form. Okay, cool. I think this should be good. And you can either unmute yourself to ask a question at any point in time, or you can do it in chat. If I miss something in chat, can someone like let me know too? Okay, so the topics we're going to go over is density, temperature, energy and nutrition, specific heat and isotopes. So I often see a lot of students miss problems on these. And I have also worked with Dr. Tran for 3 semesters now. So she has also put her input in for this workshop. So can anyone tell me the formula for density? You can look at your notes. It's not like a closed note thing. So whenever anyone has the answer to that. Yeah, perfect. Okay, so yeah. So it's going to be mass over volume. And a trick to remember this is DMV, like the Department of Motor Vehicles or something like that. Yeah, so that's something that I use to help remember. And we can go over some practice problems. Okay, so the density of octane is 0.703 0.702 grams per milliliter. What is the mass in kilograms of 875 milliliters of octane? So the first thing you do when you approach a density problem is to list out your given units, which is grams per milliliter. And it tells us that it's the density, right? So let me rewrite the formula, right? And we would plug in what we have, 0.702 grams per milliliter. And can anyone tell me what else we have? Yeah, volume, perfect. Okay, so 870, move the chat real quick. 75 milliliters, right? And we're missing mass. So what do we do after we set the equation up? Do we divide this by this, or do we multiply? Or yeah, perfect. Thank you, Seth. So yeah, you would multiply 875 on both sides. And then can anyone tell me what they get when they plug this into their calculator? Yeah, thank you, Melanie. 614.25. And what are the units? Grams. Yeah, perfect. Thank you, Matthew. So since the question is asking in kilograms, what do we need to do? Because this is not our final answer. Perfect. Thank you, Seth. So can someone tell me the unit conversion factor for grams to kilograms? Perfect. So would this 1 kilogram be on the top or the bottom? Oops, I didn't mean to make that. Top, yeah, perfect. 1 kilogram over 1,000 grams. And just to make sure that it is in the correct spot, we can cross cancel these. So we're left with kilograms. So 614.25 divided by 1,000. Can anyone do that in their calculator? Yeah, perfect. Okay, so 0.61425 kilograms. And is this the final answer? Or are we missing one step? Yeah, okay, so perfect, yeah. So in order to figure out how many sig figs we need to go back to the equation, right? So since the density has 3 and the volume also has 3, then it's pretty straightforward, right? So we would just usually would take the one with the least amount of sig figs when it's multiplication or division. But since they're the same, we have to put their answer in 3 sig figs. So what would that look like? 0. What? In 3 sig figs? Okay, so for going back to your sig fig rules, when you're multiplying or dividing, you would take whatever number has the least amount of sig figs. So if this was 0.7 and we had to multiply 875, we would use the 0.7 because it has the least amount of sig figs. So 1 sig fig. If this was 0.7, then our answer would have to be in 1 sig fig. But since both of the numbers that were given to us were in 3 sig figs, our answer has to be in 3 sig figs. Yeah, okay. Great question, Oscar. Okay, so yeah, I think a couple people put in chat, this would be the final answer. Does anyone else have any questions on how we got to this point? No? Okay. So since we did one together, now we're just I'll go through the steps one more time, and then you will be able to do a practice problem on your own. So just a recap, when you're given a density problem, you set up the equation with whatever you're given, identify what's the missing variable that you need to solve for, then check how many sig figs your final answer has to be in, and the correct units it has to be in. So let me go ahead and erase the board and then move on to our next problem. So this is a different version of the problem of a density problem. So when Sally adds a 0.83 gram rock in a 700 milliliter beaker of water, and it rises to 750 milliliters, what is the density of the rock in grams per milliliter? So I'm going to give you all a couple of minutes to solve this, and then we'll come back together and see what everyone got, okay? No, I'm not sure which type of calculator you would need. I'm sorry, I think you'd have to check in with Dr. Tran on that one. Good question, Iris. Okay, so for the volume, for this problem, yeah, you're on the right track, yeah. So when you set an experiment like this, so you would have that beaker, right? And it already has a certain amount of water. So this is like the volume initial, right? And then once you place that rock in, it displaces the water. So then the water level rises and that will be your V final. So it would be your volume, your total volume would be V final minus V initial. That helps you. Yeah. Does that make sense, Iris? Okay, perfect. Okay. So give you 1 more minute to solve it, and then we'll come together. Okay, so we kind of already started a little bit doing the problem. So this was the volume, so 750 milliliters minus 700 milliliters. And that would go on the bottom, right? So 50 milliliters equals density, and it gives us also the mass. So let me erase this drawing. Okay, so and everything is in the correct units. And so you just divide 0.83 by 50. And what did someone get? 0.0166 grams per milliliter, right? And is this in the correct sig fig? 0.02, okay, 1 sig fig. Okay, so yeah, so when, yeah, okay, 0.02 grams per milliliter. And we got that 1 sig fig from this one, right? Because this one has only 1. And then this is 6, so this would make this round up to 2. Does anyone have questions on this problem? We rounded because we needed to put the answer into 2 sig or to 1 sig fig. Does that answer your question? Yeah, okay. Any more questions on this problem? Zero 0.2. Because that would make it, so when you rounded, you would only change this digit, right? So if we were to put the 2 here, it'd be like this, right? It'd be 0.20, and that's not the same thing as this. So this wouldn't, you're only changing this digit. Yeah, okay. So let's go ahead into the next problem. Okay, so for temperature, does anyone know the formula for Celsius? Formula as in like you're supposed to know the conversion factor, or yeah, the conversions from Celsius to Fahrenheit and Kelvin, right? Okay, so we have Seth that gave us this. Oops. temperature in Fahrenheit, just do like that, minus 32 over 1.8. And let me, sorry, my screen's frozen. Wait, hold on. Can everyone still see me? Is my connection like unstable? No, yes. So this is, yeah, okay, thank you. Okay, so FTF Fahrenheit, right? Minus 32 times 5 over 9 is in your textbook. Okay, and 5 nines. Does everyone see where 5 9? Yeah, does that look familiar? I see everyone saying 1.8. I think that's the same thing as 30, this part, right? Yeah, okay. So what would, when we rearrange this to get TF on this side, what would this side of the equation look like? Yeah. Okay. So we have temperature for Celsius times 5/9 plus 32. Thirty-two. Okay, so I think this one's the easiest one to remember, the Kelvin one. Does anyone know the Kelvin one? Yep, perfect. Yep. Celsius just plus 273. And give you a second if you want to screenshot that before we move on. Okay. Okay, so how would we convert 32 degrees Celsius to Fahrenheit? So I'll rewrite formula. Just plug it in, right? So we would just have 32 degrees Celsius times 5/9 plus 32, and put that in your calculator. Iris got an answer already. 5/9 plus 32. Did anyone else get a different answer? Or does everyone conclude that it's 89.6? So sorry. Sorry.
Wait, I redid the math and this time I got 49.7 repeating.
Mm-hmm. Okay, so 49. Okay, we got another 49.7. Okay. Wait. Hold on. Give me one second. This also does not. Oh, sorry about that. Yeah, I also got 49.8. So Iris, is it just Iris who like can't hear me? No, I can't. Okay, that's because I got out for a second. Audio is okay. Okay, cool. So I got 32 or not 32, 49.8 as well. Yeah, yes, Iris?
Yeah, so I noticed if I use the formula you gave us, we're able to get that 49 number. However, if we use that 1.8 formula, then you get the 89.6.
Okay.
Super weird because that's the one we got in lecture. So it's like,
Okay, so let's just use the one you guys got in lecture, or sorry, you all got in lecture. Because if Dr. Tran gave that one, then it should be okay. So yours was 1.8 times T times C plus 32. I think that's what the chat said. Let me put back. Is it 30? Did her lecture say 35 or 32? Because different people are putting 32. Okay, 32. So plugging 32 into that. 32 times 1.8. So, but yeah, then that would get 89.6 degrees Fahrenheit. And in the sig figs, what would that be in? 90. Yeah, perfect. 90 degrees Fahrenheit. Yeah, thank you, Iris. Okay. Did you have another question, Iris, or did your hand, is your hand?
oh, sorry, I forgot to put it down.
No, it's okay. It's okay. Okay. Let me go ahead and erase this. Okay, and then if we wanted to convert it into Kelvin, what would that look like? Reminder that Kelvin is Celsius plus 273. Perfect. 273 plus 32 is 305 Kelvin. And in, yep, perfect. Yeah, and in the sig figs, what would it turn to? $310. Oh wait, no, 310. Okay, no. Okay, so kind of on the right track, right? Because you want to, you see this 5, so we know we have to Yeah, wait, 310. Yeah, wait, well, you doubted me, or you doubted yourself doing that. Yeah. So yeah, this 0 turns into a 1. Yeah, and then it'd be 310. Yeah. Okay. Okay. Sorry. Sorry for that confusion. Any questions on this one? Is this pretty straightforward? Okay. Perfect. Perfect. Okay. Cool. And then another one, so we're gonna go the other way. So 200 and we started with 298 Kelvin, and we want it in degrees Celsius. Okay. This is the formula, right? Okay, and then when we plug this in, 298. What would that give us? $25. Yeah, perfect. 25. Yeah, that's, yeah. Yeah, yeah. 25 degrees Celsius. And notice that it has to be in 3 sig figs. If she asks this, how would we make this a different notation? Yeah, perfect. 25.0. Okay, thank you, Seth. And then going a step further, converting this into Fahrenheit. Let's see. Iris got 77. Did anyone else get that same one? But do have to do sig figs and decimal rule because, yeah, good point, good point. Okay, so considering the sig fig rule for multiplication, right? How much would this product be? Or how many sig figs would this product be in? 2, yeah, so 2 SF for this portion, right? And then so 25 times 1.8 is 45. And that would still have the same 2 sig figs. So plus 32, the rule for addition and addition and subtraction would be use the least amount of sig figs. And since they both don't have any decimal spots, it doesn't matter. So 77 degrees Fahrenheit is right. It just happens to end up like that, or the same one, I should say. Does that make sense? Yeah. So if this was, was 32.58. Oh, that's not a 5. Okay, 5.8. Ignore like context of the problem, but just this as a sig fig problem itself. What would this be? How many sig figs would the final answer be in? 3? Yeah, it's 3 because of this decimal spot, not because it's 3 sig figs. Does that make sense? It'll be 77.0. For addition and subtraction, it's most. Okay, so for addition and subtraction, it would be based on the decimal spots. So for this one, maybe it will help if I write it like the like this way. Let me clear that for more room. It would be 3 sig figs because this has the least amount of decimal spots. For multiplication and subtraction, or for multiplication and division, it is the least amount of sig figs. So plus and minus, look at decimals. And then for multiplication and division, it is just the least amount of sig figs. Does that kind of help straighten it out, Oscar? Yeah, okay, cool. Any more questions before we move on? Okay, so moving on. We're just going to fill out this so we can back at it. So how many joules are in 1 kilojoule? 1,000, perfect. 1,000, and then how many joules are in 1 calorie? 4.184, perfect. And then for 1 big cal, how many little cals are there? Perfect, 1,000, which is also equivalent to how many kcals? Yeah, 1, perfect. Thank you, Iris. Okay, and then I'll give you a couple, of seconds to screenshot if you'd like. Reminder again that this will be in the YouTube, on the YouTube channel. Let me go ahead. I don't know, I think just in case someone else joined, there's a link if you'd like to view it. Will be posted Saturday morning. And here's the Google survey form. I know that some people have to leave early, so I'm just reposting it just in case. Okay. Yeah, I can. Let me DMU the formula real quick. Or actually, let me go over this first. I'll DM you in a second. Okay, so for the problems here, it is cal food and cal energy. Technically, both are for energy. The ones you see on your nutrition labels are the big C's, but they're both units of energy. Yeah, okay. So if a 4-ounce steak provides 260 joules of energy when metabolized, how many calories are obtained? How would we set this up? Yeah, perfect, yeah. So it would just be 260 joules, set up the, yeah, the 4 ounces, it doesn't matter. Yeah, so we would set up the conversion factor. So would the 1,000 joules, or not with the 1,000, would the 4.184 joules be on the bottom or the top? Bottom, yeah. 4.184 joules per 1 cal. And then since it's on the bottom, we would divide, right? And then the joules cancel out. So 260 divided by 4.184. Can anyone tell me what that equals? $62.141 Okay, and then in the correct amount of sig figs, what would this answer be in? Would be, sorry. 62, yeah. Okay, there you go. Cal. Any questions on this one? No questions? Okay. Moving on. Sorry, this is a long problem. A cup of white rice contains 45 grams of carbs, 0.40 grams of fat, and 4.3 grams of protein. How many kcals does this cup of rice contain? Given the caloric values for carbs, fat, and protein are 4.0 kcal per gram, 9.0 kcal per gram, and 4.0 kcal per gram, respectively. And this is one of those nutrition problems, and I tried to mimic as best as I could Dr. Tran's style of questions. So this is my version of it. How would we set this up? I know there's a lot of information. What is the question? What's the first step for this question?
Probably organizing it into sections from carbs, fat, and proteins so we can know the caloric values as well as how much of it so we can multiply and then add.
Yeah, perfect. Okay, so Iris, which one do you prefer to go over? You want to go over carbs, fat, or protein?
Like what we're gonna use in this problem?
No, like since we're gonna use all of it, which one do you want to start with?
I'll probably start with carbs, fat, and then protein because that's the order the data is listed in. So it'll probably be easiest.
Okay, so 45 grams, and then we're doing this for carbs. Okay, so 45 grams, how then would we use the 4.0 kcal per gram?
We would just multiply it by 4.0 kcal over grams. That way we can cancel out the grams and then figure out how many kcals are in a certain amount of the carbs.
Yeah, so for this, since it's 4.0 kcal per gram, the gram would technically be on the bottom of the, and I mean that by this kcal per gram. That gram would have been on the bottom per 1 gram. So this grams would be here and we would divide it. So close, like very close. So it was just the dividing and multiplying part. But yeah, I feel like you knew what you were doing. Maybe it was just a small mistake. So here, 45 divided by 4. Does anyone have that? Oh, wait, oh, I'm so sorry. Wait, no, you were right. I was literally, okay, I'm so sorry. I apologize. No one said anything. Okay, now I feel so bad. Iris is right. I'm so sorry. I literally stared at it. Okay, I'm so sorry, Iris. I'm so sorry. Okay, sorry. It's a Friday. Okay, so the grams cancel out. And then you multiply it. That is literally my bad. 45 times 4 is 180. Okay, 180. And you can't really see that using this purple, so I'm going to rewrite it. 180 kcals. And since this is just for carbs, I'm just going to write it on the top right here because I don't have space. Kcal for carbs. We know we're going to have one for fat and protein. Okay, so I'm going to go ahead and erase the one for carbs, and we're just going to do the exact same thing for fat and protein. So for fat, it would be 0.40 grams. My bad. And then so The grams do go on the bottom, 9.0 kcal on the top. These do cancel out, and that's why it's important to check if they cancel out. 0.40 times 9 is what? Wait, 3.6. Perfect. 3.6. We're going to move this over here to the top. Okay. And then last part, the last one is the protein. 4.3 grams. 1 gram, 4.0 kcal. Okay, and then what is this? Seventeen point two. 17.2. Okay, and then the very final portion of the problem would be to just add everything up. So 180 plus 3.6 plus 17.2 is 200.8, which is what Iris got. So good job, Iris. So sorry. Does anyone have any questions on this problem? No? Okay, yeah, so this is basically just a really long unit conversion problem with multiple steps. Okay, so let us move on to specific heat. So can anyone tell me the formula for specific heat? And this is just, I meant to make this the title for specific heat, but this is just heat. Ignore this. Yeah. Yeah, I believe when Iris that is rearranged, it will be the heat equation. So Q equals M cat. I use like M cat. So this is what? What does this represent? What does the M represent? Mass. Yeah, perfect. Mass. Okay, so this, what does this C represent? Yeah, specific heat. Specific heat, and that's usually given to you because it's specific for each substance. And then TF or delta T is TF, the final, minus initial. Okay, and then any questions on the formula? Again, I would like to say that this isn't supposed to be here. Yeah, okay, so actually applying the formula. So how many joules does it take to raise the temperature of 65 grams of water from 45 degrees Celsius to 85 degrees Celsius? Specific heat of water is 4.184 joules per gram degree Celsius. Okay, so I'm going to go ahead and rewrite the equation here for us to go. Which which variable are we solving for?
For heat.
Yeah.
Q.
Perfect. So for Q, Q equals, what's our mass?
65 grams.
Thank you. And then our specific heat. Thank you. 4.184 joules per grams degrees Celsius. And then for our delta T, -85 minus 45 degrees Celsius. Okay. So before we move on, is everything in the correct units? So we could just do the math, essentially. Yep, yeah, so grams, degrees Celsius. So that means Q will equal, X amount of joules. So first, we would do this, right? Which I believe someone had already put in the chat. I think 40, yeah, 40 degrees Celsius. And since they both have no decimal spot, this is correct. And we will carry that 1 sig fig to this answer. So we'll just make a note about how the final answer will be in 1 sig fig. So pulling everything down, 65 grams and 4.184, we can just multiply all the way across through.
Wait, and it's 1 sig fig because of the 40?
Yeah.
Okay. So if we have like an equation and then inside the equation we get a different answer, like, so you know, we have a main equation and we have like parentheses in here, so it's an equation inside of an equation. If one of those gets a different answer, then we can use that answer to apply to sig figs or like the decimal rule if it was like adding. Is that what you're saying then?
Yeah, so when considering sig figs for a specific heat, the specific heat never counts. We never factor that in because it's an exact, so we don't have to use this. But because this is like addition and subtraction within, like you said, an equation within an equation because of the parentheses, we would use the plus and minus sig fig rule in here, and then we would do whatever we get here. So if this were to equal like 0.452 or whatever, we would want to keep the 40.52 in our calculations, but make a note of how many sig figs and then apply the sig fig rules at the very end. If that does that make sense? Yes. Okay. So, but for this specific problem, it would just be 65 times 4.184 times 40, and I think someone already got the answer. Did anyone put the answer in? I don't think so. Can someone tell me the answer? Iris got 10,000. Okay, which is right. So 10,878.4 is the calculator answer. And then turning it into 1 sig fig, it would be 10,000 joules. Yeah, correct. Okay. Does that make sense to everyone?
So, because I know you said that you would use the sig figs from the 40 degrees Celsius, but I thought you're supposed to use the natural numbers that were just in the problem up here, like on the actual question itself.
I'm saying. Yeah. You would use it in the, you would use the like the given numbers.
Could you repeat that?
You would use the given numbers to set up the equation, right? But within that equation, it tells you which sig fig rules apply. Does that make sense?
I think I need to let that marinate a little bit.
Okay, but if it's any comfort to any of you, in her specific heat problems, she won't have like, so you know how it's multiple choice, she won't have like this says A and this says B. They'll be different numbers because she wants to focus on you knowing how to set up and solve the problem rather than yeah. Yeah, so but for the, I just do this so everyone can be in the routine of applying sig fig rules, because she still does have sig fig questions, but like for like specific heat problems, usually it's already a hard topic enough, and I don't think she will try to, her answers won't try to trick you, if that is any comfort to anyone. But usually her exams are pretty, her practice exams are a pretty good reflection of how the test will be. So if you all did the practice exam and you felt comfortable and did well on that, I think you all should be confident for the upcoming midterm. Other than that, are there any more questions for this problem? No? Okay. So moving on, we have how many kilograms does it take, or not kilograms, sorry, how many kilojoules does it take to raise the temperature of 675.05 kilograms of water from 75 degrees Celsius to 155 degrees Celsius. So the specific heat of water is 4.184 joules per gram degree Celsius. So how would we set this up?
Would we start with 675.05 for the mass and then multiply it by C, which is specific heat, so 4.184 joules over gram Celsius, and then multiply it by delta T, which would be 155 minus 75, which is 80. And then once we get that answer, we need to convert the kilograms into kilojoules. Okay.
Okay. So super close. One step. Okay. So before we can multiply this by the specific heat and the delta T, do you notice anything about the units? Yeah, so we'd have to convert kilograms into grams first before we can actually put it into the equation. Yeah, so 1 kilogram over 1,000 grams. So we multiply that and we get 675,050 grams. And then that can be plugged into our equation. Sorry, we're just gonna M, and then this one will be C, 4. And then delta T, 155 minus 75. To get Q, which will be in joules, and you are correct, we do convert it into kilojoules after everything. And you had said this was 80. Celsius. Bringing everything down. Oops. 5050 grams. 4.184. Right. Okay, and multiply them all together. That's okay. It could be right. What did you get? Yeah, so 675050 times 4.184 times 80 is a big number, right? And that's why there are bigger units, right? So we get our raw number would be 2,259,52736 joules. And for how many sig figs would this turn into to make our lives a little bit easier? 2. Why do you say 2? Olani, if that's how you pronounce your name. Correct me if I'm wrong. Okay, I'm getting a lot of ones. Yeah, okay, one right for this 80. Okay, so what would this turn into?
2.
2. Okay, just 2, and everything else would be zeros. So let me erase this part.
Yes, let me divide it by 1,000. Because we would multiply it by 1 kilojoule over 1,000 joules to cancel out the units.
Times to the power of negative.
Would we technically be able to do the sig figs after we converted to kilojoules, or would that be incorrect if we did it that way?
Oh, you can do it after the conversion.
Would the number just be out of pocket? Oh.
No, I think it would be the same thing.
Okay, cool. Thank you.
Yeah, okay. And when you divide it, 1, 3, 6, 7. 1, 2, 3, 4, 6. 8. Okay, and then what would we get? Yeah, 20. Yeah. There's, yeah, 6 zeros. Yeah, okay. Kilojoules. Any questions on this problem? Seems like everyone's kind of getting it. Okay, cool. So let us move on. So it took 3,400 joules to raise the temperature of 42.0 grams of water. If the final temperature was 72 degrees, what was the initial temperature? Specific heat of water is 4.184 joules per grams degree Celsius. So what variable are we trying to solve for?
TI.
Let's see. TI, perfect. Okay, so filling everything in, what would go in the Q?
Um, 3,400 joules.
Thank you. And then for M, (42.0). Then specific heat stays the same. And then for this one, for the delta T part, how would this look?
We would do 72 minus TI.
Thank you. 72 minus TI. Okay, so in order to isolate this variable, right, we would have to solve it as close as we can, right? So what would our first step be?
Would we be able to divide 42.0 G and 4.184 joules over grams Celsius to the other side? Because we need to isolate the initial temperature.
Yeah, so just to make it easier, we would multiply 42.0 and 4.184, and that would give us a number that we could divide here, right? And that number would be 175.728. So this cancels out right here on this side. And just a reminder, since this is the specific heat, this doesn't factor in for the sig figs. So we would just use the one here. So let's just make a reminder that this was 3 sig figs. Okay, so we can solve this, right? So 3,400 divided by this number, what do we get?
Uh, 19.34.
Okay, so we get 19.34. I'll just add another one. But knowing this has 3 sig figs, this has 2 sig figs. So we know this should have had 2. So I guess this is okay. This is fine. 72 minus TI. What do we do now?
We could add TI to the other side and then subtract 19.34 from 72.
Yeah, so you can add TI to both sides, making this equation look like this. Let me make some more space. TI, oh. TI plus 19.342.
Quick question though, because I noticed the 19.34 is the unit for that joules.
No.
Or did we get that from 3,400 divided by 175,728, right?
The 19?
Yeah.
Yeah, you got that 19 from this.
Oh, but the joules canceled out, right?
The joules canceled out, and we know that our final answer will be in degrees Celsius, right? Because that's the unit temperature. Everything else you can assume cancels out.
Okay, cool. Thank you.
Yeah, perfect. So this, you just subtract this by both sides, and then what do you get? $52.66, perfect. 52.66, and we had mentioned earlier that this 19 would have been 2 or isn't 2 sig figs, and I guess it doesn't really matter because this one has 0 decimal spots, right? So this would, what would this actually turn to? Yeah, 53. 53 degrees Celsius. Any questions on this one?
So this one I understand we don't have a decimal because we have the number 72, but then it's like I see the other number that we had is like 3 sig figs. So it's like, do we like override that with like the decimal rule, or like?
Which number are you talking about for 3 sig figs?
So I'm talking about on the bottom left corner of your screen, it has a star and it says 3 sig figs.
Oh yeah, this 3 sig figs is for this one. This
Yeah.
one is in 2.
Oh, okay. So the answer would have 2 sig figs.
Yeah, so that's why I was sorry, I should have had a star here too. But yeah, does that help clear up? Cleared up? Yeah.
Yeah.
Okay. Any more questions? No. Okay. So I think we can move on to isotopes. So for isotopes, it's the element, but what changes? The number of protons, the number of neutrons, or the number of electrons? The electrons. Okay, does anyone? Okay, I got another electrons. You might be thinking of ions. Ions have to do with the electrons. Isotopes have to do with the mass because it has to do with the neutrons. So a lot of students get these two mixed up. Ions are for charge, which means that they have to do with electrons. Isotopes for neutrons, and that messes with the mass because the atomic mass, remember, is the number of protons plus the number of neutrons. Okay, does that make sense? Yeah. Okay, and we know that the number of protons for each element has to be the same. So we can never alter the amount of protons, or else we're altering the element itself. Okay, so just having that foundational concept, we can go to the actually one more thing I need to go over. So there's when we're dealing with isotopes, there may be a notation that might be useful. So it would be an element X, the mass would be on top, and then the number of protons would be on the bottom. Does this notation look a little bit familiar? Yeah, okay. So for our problem, for carbon, how many number of protons does carbon have? Oops, sorry. Oops. It might be useful for you all to grab your periodic tables. How many number of protons does carbon have? Okay, I got an answer of 6. Does anyone agree? Okay, so it is 6 number of protons. And then how about for the number of electrons? 6 as well. And we know that because carbon by itself, this is a neutral, there's no charge. So the number of if there's no charge, the number of protons are equal to the number of protons if element is neutral. Okay, neutral as in if it's not an ion. So for the number of neutrons, remember that it's the number of protons plus the number of neutrons equals the mass. So how many neutrons are there? There's not necessarily an electron formula, but we will go over ions in a little bit, but there's not such thing as like an electron formula. And then for the neutrons, it would be protons plus neutrons equals the mass. So let me put that there. But mass minus atomic number. So yeah, the atomic number is the number of protons, so it's like the same thing. Does that make sense, Iris? Yeah, okay, so how many, if the atomic mass of carbon is 12, right? Oops. It's 12. And the number of protons is 6. How many neutrons? Yeah, thank you, Seth. Yeah, there's 6 neutrons. So any questions on how we got this? Okay, so moving on to carbon 13. So another notation she might have you see this is C13(6). How many number of protons are there in this isotope? This is 13. Yeah, yes. Six. Okay, yeah. Number of protons is 6. It's still carbon, so it still has the same number of protons. How about the number of electrons? Yeah, atomic number. Okay, so protons is 6. How about electrons? 6 as well. And no, there's no charge associated with it, so it's neutral. So for the number of neutrons, right, we would have 13. Number of neutrons. Yep, 7. Perfect. Any questions on the isotope version of this problem? No? Okay. Oops. Okay, for aluminum, what would the number of protons be? Thirteen. 13. Then the number of electrons would also be 13, right? And then for the neutrons, what would it be? This is 27, and that's how we got the 14. The atomic mass, sorry, the atomic mass. Yeah. So for these specific problems, when it's asking about protons, neutrons, and electrons, you would round to the whole number, because there's no such thing as like 0.9 of an electron. But yeah, good question, or good point to bring up. Anything else about this problem? It's done. So go ahead and move on. If you have any other questions not pertaining to these slides, or maybe pertaining to these slides, you can go ahead and stay after and ask a question, and maybe I can help you with it. So for this ion, this aluminum +3 ion, what would be the number of protons? $13, right? Yeah. Yep. It stays as a 13. Huh? Perfect. Yep. This would also stay as 14. Electrons would change. So typically a normal aluminum would have 13 electrons, right? But since this is +3, did we gain 3 electrons or did we lose 3 electrons? We lost 3 electrons. So yeah, correct, Iris. There is 10 electrons left or in this ion. Any questions on how we got this? But yes, if Iris, if you were wondering, you could also set up your equation like that. It's the same thing. But anything else for this question? Okay. And then for fluorine -1, how many number of protons are there? Nine. 9. Then the neutrons. 10. 10. And we got that from 9 plus blank. The atomic mass was 19. And then for the number of electrons, a normal fluorine would have had 9 electrons. But since this is a -1, did we gain or lose an electron? Gain, yeah. So we would have a total of 10 electrons. Think makes sense? Okay, so if we wanted to put this in as the electron configuration, we'll just do this as extra practice. Helium, 2s2, 2p5 is the normal one, right? Is normal fluorine. How would we make a fluorine with a -1? What would change for this? Yeah, 2p6. So this is the same because it's filled up. We don't touch it. 2p6, right? Because this would be the number of electrons, and this -1 indicates that we have an extra one. So we would just fill in the 6th orbital. If there was an element with a -2, you would just go to the next sublevel, right? The next energy level if you have to, because I think this one goes to 3s. Any questions on that one? No. Okay. And I think that is it. Yep. And thank you for all attending. Like I said, I'll post the survey link again, just in case, so you don't have to like dig through the chat for it, and also the link to the YouTube. Here's the YouTube one. Thank you so much for coming. If you have any questions, feel free to stay here or DM chat me if you want to. But yeah, this concludes my workshop. Thank you all, and good luck on your midterm. Yeah, welcome. Thank you. Bye, everyone. Yeah, no problem. Hey, Adriana, did you have a question?
No, I think I'm good.
You're good? Okay.
Yeah, thank you.
Yeah, no problem. Have a good weekend.